Hello everyone, this is Hussein. I used to be a PhD student here. I graduated last year, December 2022. Today is February 4, 2023. This is a tutorial video on how to use wireless accelerometers. These wireless accelerometers are product of microstrain.com. Lord, the product's name is Lord. These ones are called 40G. They are capable of, come on this side, of giving you acceleration versus time in X, Y, and Z. 1, 2, 3. Or you can get on one axis or 2 or 3, and you also need batteries. And the way I have connected to my frame, I have taped the frame, taped the base of the accelerometer, and I have epoxied both. So in case in the future when I want to take this off, or another student wants to take this one off, they can take it off without damaging the frame or the device. If you go back on the computer, you go on that website, microstrain.com, you download their computer program, Sensor Commander, which is this one here. Sorry, Sensor Commander was the previous one. The new one is called Sensor Connect. You download this app on your device, and they also come into different versions. Always go with the latest version, and you need to have a base station. These kind of accelerometers go with USD8 base station, this kind of model. The old ones, which are for the 10G accelerometers, this one doesn't work with that kind of accelerometer. So for that accelerometer you need to have this. And at Old Dominion University in Norfolk, Virginia, USA, we have this one for that one, and we have this one for the old accelerometers, the 10Gs. As I mentioned, the new one is 40G. This one is a wireless, so you connect your accelerometer wirelessly to your base station through this antenna, and your base station is connected to your computer through this USB. This is your base station. It's not active. When you connect it, it gets activated here. Give it a second or so. Here I have four accelerometers. None of them is active because I've turned all of them off. I have two here, two here. These two here is what I use for this tutorial video. One on the top floor of the frame to get acceleration versus time on this axis, on Z-axis, and I have another accelerometer on my pendulum, my forcing function. So I get my forcing function equation. I have the weight of the pendulum. I get G versus time from this. So weight times G is force versus time. And then here I get readings, acceleration in G versus time. And later on, whatever approach you use, you can convert your readings here to velocity and displacement as well. I used finite difference method for this frame. I was able to run it for 5 seconds. I used Microsoft Excel. I programmed 9 million cells just for the base column, this column. So if we come up on the screen, here now we have the base station. The base station is active, but none of the accelerometers are active. We turn them off. You take this cap off, but don't mix the caps. Each cap have a code here, like 6749 is this one, 6749. You just one click here, this red button. It blinks until it connects. When it connects here, it goes bold. It means it's connected. And I also connect the bottom one. So just remember the top one is, let's say the last 2 digits is 49, and this one it's also connected. This one is 40. So 40 is the bottom one, 49 is the top one. 40 and 49. 49 is on the frame, 40 is on the pendulum. Now what we do, here is the trick. It took me months to find out this. If you activate the nodes on the nodes, you just can have one reading at a time. Let's say this node, I set it idle, collect samples, apply. It doesn't. When you come here, you can get readings only from that accelerometer. But if I go back here, set it on idle. If I go to the base itself, always set it to idle, not from the base, from the accelerometers. When you come here, you collect samples, do configure, sample. It gives you all of it. See, it fails it. Why? Because it gives you only 4 readings at a time. Now I have 3 channels here active, X, Y, and Z. I reduce it to 1 channel here, and this one channel. So I have channel 1, 2, 3. So 1, 2, 3. 3 is this way, and I excite the building this way. That is why I activate only 3. See, 3 goes this way. I don't need 1, I don't need 2, I need 3. If you are interested about X, Y, Z, then you can have a reading at 1 node only. Then you activate all 3 channels on 1 node. Otherwise, you just do what I did here. Now I have this active. The ones I don't need, I select them. 1 channel here, 1 channel here, that's 2 channel, 50% capacity. I say apply. One more thing here, very, very important, took me months to find it out. Your frequency, see, it's on 512 hertz, 512 hertz. When it gives you the readings, it gives you the readings in times, like it says 3 p.m., like 3:25, 3 o'clock, 25 minutes, 1 second, 25% of a second, and then it goes from there. It goes time-wise. By time, it doesn't go in seconds, like 1 second, 2 seconds. No, it goes by hertz. So that 512, later on, I'll show you in the Excel sheet how you convert the readings to seconds. So now we have both channels active from both. See the red, the green nodes on. Now we go to data. This I take it out. I get a new one, widget. I'm interested in time series. You can get it in the other formats, but that's what I want. I want this one, 40. I select channel 3 here. 49 on top of the building, channel 3. Now it gives me both readings, but now you don't see it because they're both on each other. But here it says node 6740, node 6749, both are active, and the readings on y-axis is in G. On this direction, since the time is 16:55:30 here. And now if I excite it, I just pull this guy, hit it once, and if you come back here, the red reading is your forcing function, and the green is your building's response after the impact load on it. So now you have 2 readings simultaneously at the same time. If you wanna export the data, you need to have a mouse here. You just select it. Where is it? Yeah. Here you go. See 1656, it says from 1656 to this time, standard, export, and you can export it to your desktop, but the data is CSV. You cannot make changes there. First of all, convert it to Excel, EXCL. Where's my data? It is this one. This data is in CSX. First thing, convert it to Excel, and I'll show you how you do it. Make sure it's focused to the full screen, please. File, save as, let's say test. This converted to Excel, Word Excel, then save it, and then work on that one, this one. Here I can make changes, I can do my plots. See, my time is 56:22. Those kind of readings are so hard to change. For example, if I plot both, select data, first forcing function. On x-axis we have time, on y-axis we have acceleration in G. This is channel 6740. 40 is, this is my forcing function. This is not my mouse, it's so hard to use it. This is your plot, but the problem is with your time. Your timing is so hard to use in your calculations. So let me add, this is the force, add the, let's say, top floor response. On x-axis we have time, on y-axis acceleration in G along the forcing function direction. This is the two readings. I need to fix this. Transparency, let's make it 50% so we can see it on each other. 50%, yeah. That looks like 5618. Select data, take out top floor. We didn't get the forcing function. The beauty of this is you can always come back. Okay, so this is our data. I kind of had to stop the video for a little bit so I get the data from the time I wanted. I got it from here and the forcing function was gone. I want it from 1655, 58, let's say from 1656 or 1650, let's go 1655, 58. Just be careful here. 58, 55, 58. That is good. It's a good capture. We converted to, so we downloaded to the desktop. Now we should have all of this. This data, as I said before, this is in CSV. the first thing you need to do is convert it to, you see if the readings are here, 58. You can do 55, 58. Yeah. 55, 58. So I got this. You need to convert it to Excel. You come to save as. Here it's in CSV. The problem with CSV is whatever change you do, it doesn't save it. Go to XLSX. Let's just name it test. Save. And now we go to this test. And here we have time. Readings on the 6740, which is the accelerometer on the pendulum forcing function, and the pendulum on the building or the frame or the model. Select data. This remove, add forcing function. On x-axis we want time. We want acceleration in G. That is our forcing function. Yeah, this time we have captured the force, so it's up to 9G. Now we include the building's response. Add, let's say, building. On x-axis the same thing, we have time. On y-axis we have acceleration in G on the horizontal direction along the forcing function direction. Now we go back to the top. I always make this one transparent so I can see it. Maybe 40% or 50, whatever you feel comfortable with. See, now we can see both. I'm gonna do this guy this color, and here the trick is, see, on your x-axis is in time, real time. We want it in seconds. How do we do that? Your frequency is 512 hertz, so we go with steps. Step, let's say 0, 1, 2, 3, 4, 5, and so on. Just select it, double click, it goes down in numbering. Here, your time in seconds is your steps divided by your hertz, 512. And then this, double click, this is your delta T is 0.001953. That is really important to have. And for example, for the building's response, I pick this, and for the forcing function I change my time to this. Now I have my readings in seconds. See, after 5 seconds it starts. Now I can play with it, like from 5 seconds to 20, or let's say to 7 seconds, just 2 seconds of the first event. Oh, sorry, this was 5, from 5 to 7, which is 2 seconds. See, that is, the blue is your forcing function, the yellow is the building's response, and the building vibrates and it decays motion gradually. If you look at it until 15 seconds, see, that's how the building decays, and basically that is how you collect data from your wireless accelerometers from load. You need to have this kind of base station, and the beauty of this program is you can go back to even your old data. If you scroll out, it goes back to your old data. See, the green one is the building's response. It decays gradually. My dissertation was on how to make it decay much faster. And when you want to start them, just come back to devices, set idle, and the rest you don't need to mess up with, like cycle power, those kind of stuff. But one more thing really important here on configuration for each one, for each accelerometer, you can range your capacity. These accelerometers go up to 40G. You can say, okay, give me readings until 10 plus minus G, or 20 plus minus, or 40 plus minus, based on how much is your impact. If it's real high, then you may need to go up to 40G. And this frequency is just the frequency between your accelerometer to your base station. It's not related to data collection. It's not the 512 one. But here you pick what you need. For me, I didn't go beyond 20, so I just picked 20, and then you just apply configuration. This is one thing I almost forgot to mention. You go to configure for each one, like this one too. You go to for configure, it's right here. And don't mess up with calibration stuff. See, the readings are in G, that's what you want. Sampling 30 seconds. And these accelerometers are designed to be on frames for very long times, like days, weeks, months. And you can set it up, say, okay, give me readings for 1 hour or 2 hours or 3 hours. But I'm a structural engineer. In our structure lab, we are just interested for the duration of our test. We don't do long runs. We have another one here on long run, applying load and then lateral load, but that's a long run. But whatever I do here is not long run. Okay, everyone, thank you very much. I hope this video is helpful. Thank you.